day, students. Welcome to another session of learning. Today, we will discuss solving equations transformable to quadratic equations. Alright, let us begin with a review of solving quadratic equations. By any method, find the solutions of the following quadratic equations. Let us have number 1. X squared is equal to 6x plus 7. Previously, we have discussed the four methods in finding the solutions of quadratic equations. In this case, we can use factoring. But before that, let us write this into standard form as x squared minus 6x minus 7 is equal to 0. Then, let us write the left side of our equations as factored form, and it is written as the product of the quantity x plus 1 times the quantity x minus 7 is equal to 0. To solve for the first value of x, we can have x plus 1 is equal to 0, and then x sub 1 is equal to negative 1. And then to solve for the other solution, we have x minus 7 is equal to 0. Then our x sub 2 is equal to 7. Therefore, the solutions are negative 1 and 7. Let us have number 2. X squared is equal to 144. In this case, since it is written into the form ax squared is equal to c, we can use the other method on finding the solutions, and that is extracting square roots. So let us write the square root of the left side and right side of our equation. And then the square root of x squared is x. And the square root of 144 is positive and negative 12. So x sub 1 is equal to negative 12, and then x sub 2 is positive 12. Therefore, the solutions are negative 12 and positive 12. Next, we have number 3. Y squared plus 14y plus 33 is equal to 0. This time, our quadratic equation is already written in the standard form. So let us apply any method to solve for the value of y. In this case, since it is factorable, because there is a factor of 33 that will give us the middle term of 14, let us write the left side of our equation as the product of its factors, and that is quantity y plus 11 times the quantity y plus 3 is equal to 0. Because 11 times 3 is 33, then 11 plus 3 is equal to 14. So that means that is the factor. To solve for the first value of y, we have y plus 11 is equal to 0. Then y sub 1 is equal to negative 11. For the second value, we have y plus 3 is equal to 0. Then our second value of y is equal to negative 3. Therefore, the solutions are negative 11 and negative 3. Next, we have number 4. 2x squared plus x minus 15 is equal to 0. This is also written in the standard form. But as you can see, we have the coefficients of ax squared, or the quadratic term, is not 1. So it is not easy for us to find the factors. So let us apply quadratic formula in finding the solutions of this quadratic equation. First, let us identify the coefficients of a, b, and c. Our a is 2, our b is 1, our c is negative 15. Then let us use the quadratic formula. X is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a. Then let us substitute all those values, that is x equal to negative 1 plus and minus the square root of 1 squared minus 4 times 2 times negative 15 all over 2 times 2. Then let us evaluate the values. So we have x equal to negative 1 plus and minus the value of 1 squared is 1. The value of negative 4 times 2 times negative 15 is 120. Then let us combine 1 and 120. The sum of that is 121. So we have x equal to negative 1 plus and minus the square root of 121 all over 4. Then let us extract the square root of 121, and it will give us x equal to negative 1 plus and minus 11 all over 4. Then let us solve for the first value of x, that is x equal to negative 1 minus 11 all over 4. Negative 1 minus 11 over 4, that is negative 12 divided by 4, it will give us the first value as negative 3. And then for the second value of x, we have negative 1 plus 11 all over 4. Negative 1 plus 11 is already 10 divided by 4. That will give us the second value of 5 over 10 because 10 over 4 in its simplest form is 5 over 2. Therefore, the solutions are negative 3 and positive 5 over 2. Now, let's proceed to our main lesson, which is solving equations transformable into quadratic equations. In this lesson, you will encounter equations that seems not a quadratic equation as given, but when transformed, it becomes a quadratic equation. Let us have some illustrative examples. Number 1, x times the quantity x plus 5 is equal to 14. Looking at this equation, we cannot easily identify that it is a quadratic equation because there is no exponent of 2. But after simplifying it, we can discover that it is a quadratic equation. So let us simplify the left side of our equation. It will give us x squared plus 5x is equal to 14. Let us write this into standard form. And it is x squared plus 5x minus 14 is equal to 0. Let us apply any method. This time, let us use factoring. The left side of our equation can be written as the product of the factors quantity x plus 7 times the quantity x minus 2 is equal to 0. Then let us solve for the values of x. We have x plus 7 is equal to 0. And it will give us the first value, which is negative 7. Then for the second value, we have x minus 2 is equal to 0. X sub 2 is equal to 2. Now, let us check if these solutions will satisfy our equation. For x is equal to negative 7, we have negative 7 times the quantity negative 7 plus 5 is equal to 14. Let us evaluate the numbers written inside the parentheses. Negative 7 plus 5, it will give us negative 2. Therefore, that is negative 7 times the quantity negative 2 is equal to 14. Negative 7 times negative 2 is already positive 14. So, it is equal to the right side of our equation. That means negative 7 satisfies our equation. For the second value of x, we have 2. Let us substitute to the equation. We have 2 times the quantity 2 plus 5 is equal to 14. Let us evaluate the numbers written inside the parentheses. That is 2 plus 5. And it will give us 7. So that is 2 times 7 is equal to 14. 2 times 7 is equal to 14, which is equal to the right side of our equation. That means also that 2 is also our solution. Therefore, the solutions are negative 7 and 2. Alright, number 2. Find the roots of 3 over x plus 2 over 5 is equal to 2. This is a rational equation that can be transformed into quadratic equation. To solve this equation, we need to get first the LCM of the denominators x and 5. To do that, let us identify the prime factor of x, and that is x only. And then the prime factor of 5, which is 5. Then, get the product of x and 5. It will give us 5x as our least common multiple. Next, let us multiply the whole equation by the least common multiple 5x. 5x times 3 divided by x. X is eliminated, so it will give us 3 times 5. Plus, 5x times x plus 2 over 5. 5 is eliminated, so it will give us x times x plus 2 is equal to 2 times 5x, so it will give us 2 times the quantity 5x. 3 times 5 is already 15. X times x is x squared. X times 2 is 2x is equal to 2 times 5x is 10x. Let us transfer 10x to the left side in order for us to get the standard form. So it will give us x squared plus 2x minus 10x plus 15 is equal to 0. Then let us combine 2x and negative 10x. So our equation now is x squared minus 8x plus 15 is equal to 0. Then let us apply the method, any method, in finding the solutions. Let us use factoring. So x squared minus 8x plus 15 is equal to 0 can be written as the product of the binomial quantity x minus 3 and quantity x minus 5 is equal to 0. Let us solve for the first value of x by using x minus 3 is equal to 0. So our first x is equal to 3. For the second x, we have x minus 5 is equal to 0. So our x sub 2 is equal to 5. Now, let us check if these solutions will satisfy our original equations. 3 over x plus 2 all over 5 is equal to 2. Let us substitute 3 to the variable x. So we have 3 over 3 plus 3 plus 2 over 5 is equal to 2. So that is 3 over 3 plus 5 over 5 is equal to 2. 3 over 3 is 1. 5 over 5 is 1. So that is 1 plus 1 is equal to 2. It will give us 2, which is equal to the right side of our equation, also 2. This means that 3 will satisfy our original equations. Next, we have the second value of x, which is 5. So that is 3 over 5 plus 5 plus 2 over 5 is equal to 2. Then it will become 3 over 5 plus 7 over 5 is equal to 2. Since the denominators of the two fractions are the same, which is 5, let us combine the numerator so that that will become 3 plus 7 is equal to 10. And then copy the denominator, which is 5, is equal to 2. 10 divided by 5 is equal to 2. So 2 is equal to 2. This means that 5 also satisfies our original equations. Therefore, the solutions are 3 and 5. Next, number 3. Find the roots of x over x minus 5 plus 3 over x plus 2 is equal to 7x all over the quantity x minus 5 times the quantity x plus 2. Again, the same with number 2. We need to get first the LCM or least common multiple of the denominators. To do it, let us find the prime factors. For x minus 5, the prime factor is x minus 5. For x plus 2, the prime factor is x plus 2. For the quantity x minus 5 times the quantity x plus 2, the prime factors are the quantity x minus 5 times the quantity x plus 2. To get the LCM, we need to get the product of the quantity x minus 5 times the quantity x plus 2. So that will be our LCM, quantity x minus 5 times the quantity x plus 2. Next, we need to multiply the whole equation by the LCM, quantity x minus 5 times the quantity x plus 2. If we're going to multiply the LCM for the first rational expression x over x minus 5 is eliminated. So what we have now is the product of x times the quantity x plus 2. For the second rational expression, x plus 2 is eliminated. So what we have now is the product of 3 times the quantity x minus 5. Then, for the right side of our equation, x minus 5 is eliminated, as well as x plus 2 is also eliminated. So what we have now is 7x. Next, let us simplify. The product of x times the quantity x plus 2 will give us x squared plus 2x. The product of 3 times the quantity x minus 5 is 3x minus 15. Then let us transfer 7x to the left side of our equation. That is negative 7x equal to 0. Then let us combine similar terms 2x, 3x, and negative 7x. So it will give us the equation x squared minus 2x minus 15 is equal to 0. This equation is factorable, so we can apply factoring in order to find the solutions of the equation. So we have now the factored form as quantity x plus 3 times the quantity x minus 5 is equal to 0. Then let us solve for the first value of x, that is x plus 3 is equal to 0. For x sub 1, we have negative 3. For the next value, we have x minus 5 is equal to 0. So our x sub 2 is positive 5. Now let us check if our solution will satisfy our original equation. X over x minus 5 plus 3 over x plus 2 is equal to 7x all over the quantity x minus 5 times the quantity x plus 2. Let us replace the variable x by negative 3. So we have negative 3 over negative 3 minus 5 plus 3 over negative 3 plus 2 is equal to 7 times the quantity negative 3. Quantity negative 3 minus 5 times quantity negative 3 plus 2. Let us simplify. We have negative 3 over negative 8 plus 3 over negative 1 is equal to negative 21 all over negative 8 times negative 1. Negative 3 over negative 8, it will give us positive 3 over 8 plus 3 over negative 1, it will give us negative 3 over 1 is equal to negative 21 all over 8, because negative 8 times the quantity negative 1 will give us positive 8. Next, let us combine the left side of our equation. So by that, we're going to get the LCD. The LCD is 8. So we have 3 minus 24 all over 8. Because 8 divided by 8 is 1 times 3 is 3. Then for the second fraction, we have 8 divided by 1 is 8 times negative 3. That is negative 24. If we're going to combine negative 3 minus 24 will give us negative 21 over 8, which is equal to negative 21 over 8 on the right side. That means negative 3 satisfies our equation. This time, let us check if x is equal to 5 satisfies our equation. X over x minus 5 plus 3 over x plus 2 is equal to 7x all over the quantity x minus 5 times the quantity x plus 2. Let us replace the value of x by 5. So we have 5 over 5 minus 5 plus 3 over 5 plus 2 is equal to 7 times the quantity 5 all over the quantity 5 minus 5 times the quantity 5 plus 2. Let us simplify. The first fraction, we have 5 over 0 plus, in the second one, we have 3 over 7 is equal to 35 over 0 times 7. Observe that if x is equal to 5, the value of the fractions on both sides of the equations will give us the 0 denominator, which is considered undefined. Therefore, the real solution is only negative 3. 5 is considered extraneous solution because it will make the equation undefined. Number 4. Patty and Harry are going to paint the bedroom of a friend as a surprise for her birthday. Patty knows that by herself it would take her 5 hours more than the time Harry takes to finish painting the room. If they work together, they think it would take them 6 hours to complete the job. Find how long it would take for each of them to paint the room. This problem is an example of a real-life situation where the concept of a rational algebraic equation transformable into quadratic equation is being applied. Now, how do we represent this as an equation? Let us observe the process below. The representation, we let x be the number of hours Harry can finish the job. X plus 5 be the number of hours Patty can finish the job. 1 over x be the amount of work Harry can finish in 1 hour. 1 over x plus 5 be the amount of work Patty can finish in 1 hour. 1 over 6 is the amount of work Harry and Patty can finish in 1 hour. Then for the equation, let us combine the amount of work Harry and Patty and then to the amount of work they can finish in 1 hour. So that is equal to 1 over x plus 1 over x plus 5 is equal to 1 over 6. Now let us solve our equation. 1 over x plus 1 over 5 is equal to 1 over 6. First, let us find the LCM. For x, the factor is x. For x plus 5, the factor is x plus 5. For 6, the factor is 6. In order to find the LCM, let us find the product of 6, x, and x plus 5. It will give us the LCM as the product of 6x times the quantity x plus 5. Next, we need to multiply the whole equation by the LCM 6x times the quantity x plus 5. If we're going to multiply our LCM to the first fraction 1 over x, x is eliminated. So it will give us 6 times the quantity x plus 5 plus. On the second fraction, x plus 5 is eliminated. So it will give us 6x. Then on the right side, if we're going to multiply this fraction 1 over 6 to the LCM, 6 is eliminated. So we have now the quantity x plus 5 times x. Simplifying the whole equation, we have 6 times quantity x plus 5 will give us 6x plus 30. Then copy plus 6x. The right side of our equation will become x squared plus 5x because x times x is x squared. X times 5 is 5x. Combining all the terms on the right side of our equation, it will give us 0 is equal to x squared plus 5x minus 12x minus 30. Negative 12x because that is x 6x plus 6x is 12x. On the right side, it will become negative. Combining the terms 5x and negative 12x, it will give us 0 is equal to x squared minus 7x minus 30. This equation can be written as x squared minus 7x minus 30 is equal to 0, applying the symmetric property. This equation can be written as the factor of the quantity x plus 3 times the quantity x minus 10 is equal to 0. Let us solve for the first value of x, that is x plus 3 is equal to 0. Our x sub 1 is negative 3. For the second x, we have x minus 10 is equal to 0. X sub 2 is equal to 10. Now, since we do not have a negative days, therefore, 10 is the solution, while negative 3 is an extraneous solution. Going back to the problem, the question is, find how long it would take for each of them to paint the room. So let us answer the question. Since Harry can finish the job in x hours, and the value of x is 10, so therefore that is 10 hours. Patty can finish the job in x plus 5 hours, and since our x is 10, so that is equal to 10 plus 5, so that is equal to 15 hours.